very much for coming to another Climate Matters session. I'm your host, Stuart Scott, and this is a hybrid between a press conference and a very serious talk TV show that we do here at the COPs. This year, of course, we're coming to you live from COP23 in Bonn, Germany, where Fiji is the president of this year's COP. Here's my email address. I give it at the beginning and end of each of these shows so that people can write with questions. And today's guests I have with me János Pastor. He's with the Carnegie Climate Geoengineering Governance Initiative, C2G2 for short, and he was formerly a senior climate advisor to Ban Ki-moon, working for the United Nations. Dr. Yu Hunt, he's in the Department of Engineering at Cambridge University. And Matthias Honegger, who's got two hats. He's with the Institute for Advanced Sustainability Studies and Perspectives Climate Research. Today's show we're calling Can We Refreeze the Arctic? Trying to establish the need for climate engineering governance. So first I'll give the mic to Matthias.
Yes, thank you, Stuart. So what is actually the context of this discussion? In Paris, the temperature target of limiting warming to 1.5 or well below 2 degrees was reached. But stabilizing global temperature at any level requires to reach a balance of sources of greenhouse gases, of emissions, and sinks of removals of greenhouse gases from the atmosphere. Now, are the national targets actually on track to reach those temperature targets, to limit warming to 2 degrees at the maximum? Well, we just heard from the UN Environment Gap Report, which says basically in 2030, the NDCs, the national mitigation actions, represent 1/3 of what's needed to achieve that. What's more, a balance of sources and sinks requires that there's active removal. And that is actually expected in the economic models on which we base our assessments of climate targets. And as you can see on this graph, the red line eventually reaches net zero, which is the sum of residual emissions minus the removals that are taking place at that point in time. We can do a lot. We have to do a lot. We have to try much harder at cutting our emissions. But there will remain certain emissions, especially in the land use sector, which are not going away. And so we actually need to start talking about this removal of greenhouse gases, inevitably. This removal is also known a little bit in a more technical term, negative emissions technologies. And we just heard from a panel who was talking about community efforts. And I think there's this notion of a very big solution. I don't think there will be any big solution in practice. So I think there has to be an effort at all scales. There has to be also an effort to think about how community-based removals could actually look like. But without considering these technologies or these practices, such as even just planting trees, we will run into a big problem.
I'd like to just insert that the notion of negative emissions I find to be a little bit ludicrous, almost an oxymoron. We're talking about vacuuming carbon dioxide out of the air. Calling it negative emissions makes it sound achievable, like we can go around the corner and buy some of that. But as we'll see, we really don't have that in place. So, thank you.
So even in 2030, even the important number is actually we will have used up 80% of our remaining carbon budget to reach 2 degrees, and we will most certainly already have used up the carbon budget for 1.5 degrees. So those are really numbers to be kept in mind and to be, well, they are quite unsettling. And you can see the scale of those removals. And actually the blue area, eventually you can see the red line crossing the zero level, which means that at that point, from 2090 onwards, there has to be more removal than residual emissions. And that is the only way that can bring us somewhat closer to pre-industrial climates. So how could we do this? There's different approaches being discussed, and planting trees or generally ecosystem restoration is just one of them. There's the idea to disperse certain minerals in oceans to enhance growth of algae, which then essentially, as they sink to the ocean floor, that's the theory, create a net flux of carbon from the atmosphere into the oceans. Others are the combination of bioenergy with so-called carbon capture and sequestration, which again results through this biological process in a storage and in a net removal. The next one is a little bit debated, direct air capture and storage, where through a chemical process, essentially, the air is filtered, so to speak, in order to remove the carbon from the air by a technical process.
In putting that image in, I was very careful to note that it's an artist's impression because the graphics capabilities are so good that it looks like a photograph, but this is still conceptual. This is on the drawing board, so to speak.
Yeah, but what if we actually don't do enough of this and quickly enough? Hugh, you might have a view on that.
Well, the business as usual is a little bit worrying. What we would like to achieve if we reduce CO2 emissions nice and rapidly is the diagram on the left, which shows modest increase of temperatures, perhaps 2 degrees with any luck. But even then, the Arctic regions, the regions in the northern part of the picture, are a little bit red. It's a bit warm there. If we do business as usual and things go bad, then we are left with a planet which is very warm and the Arctic which is very, very warm. This is a business as usual picture looking at the year 2090, and we're talking maybe 10 or 15 or 20 degrees warmer in the Arctic, 10 or so degrees warmer in the mid-latitudes. Now, the Arctic is our air conditioning system. If you like, warm air rises as it does in the tropics, and it moves around, and cool air descends, and there's a lovely circulation which helps to keep the temperature of the planet modest. Now, if you start to warm up the whole planet because the air conditioning system's not working, then you get droughts, or you get agriculture failing. You get floods as well because you've got sea level rise and you've got storms because the oceans are warmer, you get more evaporation from the oceans. We are heading into a very difficult situation with droughts, floods, sea level rise. We will have many displaced people. And displaced people lead to very difficult conditions. Where are the people being displaced to? They'll be displaced to other places which are having difficult conditions. So the reason we're having a discussion about geoengineering is because the concept of not doing anything is full of danger. Now, the concept of cooling the planet is full of danger as well. What kind of things might we be thinking about? Well, one thing we might think about is spraying salt water, let's say, up above the oceans to encourage more clouds to form. And if you look at the picture on the right, the image of the Earth, that image is taken from out in space. Now, if we can make the Earth a little bit whiter with more clouds, then there'll be a little bit less solar heating. If more sun is reflected away from the Earth, that will help cool things down. But we know that volcanic eruptions cause cooling as well. It's well known, for instance, that in 1991, Mount Pinatubo erupted, and there was a cooling over a period of perhaps 6 months to a year of roughly a degree. Could we emulate volcanic eruptions? So stratospheric aerosol injection is well and truly on the cards. I was involved in a project called the SPICE project, Stratospheric Particle Injection for Climate Engineering. And the research I was doing was considered controversial. And in fact, the project I was involved with got cancelled. Why did it get cancelled? Well, really good reasons, perhaps. But we were doing important research, and our research gets cancelled.
Perhaps not such good reasons, because it was maybe felt to be politically unpopular, that people were afraid of geoengineering. And this is one of the cautions I like to lay out to the environmental community. I respect CAN International greatly, Climate Action Network. They come here in large numbers to try to influence the negotiations in a very positive way. But they have some predispositions that are not helpful. And one of them is that geoengineering is a four-letter word to them, and they are not willing to even considering it now when we have the luxury of trying to figure out what works and what doesn't. I'm sorry.
So if we're going to be talking about things that are controversial, then if it's controversial, then there are going to be opinions, some people in favor, some people against. If you're going to have a controversy, you have to talk about your problems with other people. You have to discuss things. So who do you discuss things with? Were we meant to discuss things with Friends of the Earth and Greenpeace? Or were we meant to discuss things with the government, the politicians, or with other scientists, or with social scientists? We're meant to discuss this with everybody. We have to have full-on public engagement, full-on societal involvement. The reason is that the risks of climate change are huge, the risks of doing nothing are huge, but the risks of geoengineering are huge as well. So we've got to explore those risks, because who knows, we may end up entering into a world, very risky world, without understanding what those risks are.
Not may, we are entering into a very, very dangerous world.
The geoengineering risks are not well understood and need to be explored.
And it's not that we're not doing nothing, obviously. The fact that there are countries, every country has contributed a plan to cut emissions, but we just see it's not nearly close to where we need it to be. And so we know that there will be significant risks, and they're rising, and the impacts are already visible. And
now, before we go on to discuss governance, I like for the audience that will see this as a YouTube afterwards, where they are not at the climate talks, they perhaps don't know what the word governance means, they know government. Governance is how do we set up rules to control anything that's going to happen.
Well, so we know that government, the governments around the world, they govern us. And governance is a process to make sure that we get the right outcome. That if you are trying to achieve a difficult thing on a large scale, and the planet is a large scale, the quality of the governance is critical. Because if we have really good governance, we expect good outcomes. But if we have bad governance, well, we don't quite know what we'll get. And that's really worrying. When it comes to geoengineering, the last thing you would want to do is to deploy something where you don't know what's going to happen. So the research is important, but it has to be done in a correct and proper way. And that's where I'll hand over to
Yes,
Janos.
let's pass the baton on to Janos, because this is his day job.
And my night job. Thank you. So thank you very much, and good afternoon. And I'd like to say a few words now about governance, especially as it relates to stratospheric aerosol injection. That doesn't mean that the other geoengineering options do not have governance challenges. They do. But I think the one related to stratospheric aerosol injection is of particular relevance. And this technology is absolutely terrifying, isn't it? The challenge is that we may actually need it. And we don't know yet, but we may. But then, who do we want to decide? Do you want somebody else to decide whom you don't know? Or do you want your neighbor, or Friends of the Earth, or the different groups that have been mentioned? I think that's where this society-wide discussion has to take place. But how can we govern this kind of technology? And I'd like to run through just a few interesting, sometimes questions, sometimes observations about governance. First of all, stratospheric aerosol ingestion would be more global than anything we have ever seen. It will affect absolutely everything, in particular the one global atmosphere that we have. So it will require a level of international cooperation. It would require a level of international cooperation that we have just not yet seen. And frankly, our track record in doing international cooperation on these very complex, very complicated things is not that fantastic. So that is something that one needs to reflect. Now, starting, you mentioned, Hugh, research. And as a start, research is already taking place in this area, and there will be more research going on. And many people feel that that research needs to be governed also. And it's not just about control. It is, yes, about control, about regulation, but it's also about enabling research to go in the direction that society wants answers for. So it's both an enabling function and a regulatory function. So we need the research governance. But then, when you look at longer term about potential deployment, who will decide? Who will decide whether or not we should make use of stratospheric aerosol injection? And when should that decision take place? Should we wait until the temperature is 5 degrees above historical average? Or should we say, now we're already on a path of this, and therefore we should do it now, or somewhere in between? So even when to have that decision? And then, once you get to some kind of decision making, who will make that decision on behalf of the world? Because it will be on behalf of the world. Is it the UN General Assembly or some other mechanism? And then, even if the world were able to make a decision, how far do we turn the thermostat of the global air conditioning system? Because that's what we're talking about, setting up a global air conditioning system to cool the planet. And there are issues, because the more temperature you want to reduce, the higher the chance that there will be negative impacts. And the higher the chance that some of these impacts will not be the same across different geographical zones. So immediately you might end up in a situation where some people benefit, or maybe everybody benefits from the reduced temperature, but some people have negative impacts. And then what do you do with those people? How do you compensate for that? How do you take care of that? These are very challenging issues of governance. And these issues don't just happen in a spatial scale, that is to say different parts of the world, but once you start this kind of stratospheric aerosol injection, you actually have to continue it for many decades, possibly even longer, possibly into the hundreds of years, depending on how well we're doing in terms of reducing our emissions. Because let's not forget, this kind of approach, the stratospheric aerosol injection, is not one of these silver bullet solutions. It is potentially an addition to the things that we need to do anyway, which is to reduce our emissions. But it will have an impact on future generations, and therefore we don't only need to take care of the different parts of the world and how the impacts will happen, but also what happens to the future generations. And it's not just our children and their grandchildren, but potentially many generations to come. Now, one specific issue that arises, and there have been some interest by some expressing that one could do regional level stratospheric aerosol injection, like the Arctic. We've heard how situation the Arctic is, and people said, well, let's just do solar radiation management above the Arctic. And there is some new information, scientific information, that seems to indicate that in fact that's not a very good idea, because if you disturb the balance, the heat balance of the Earth, and you only inject the particles, let's say in the northern hemisphere, yes, you can get a reduction of temperature and even a reduction in cyclone activities, which is a good thing, but you might end up having very serious impacts on, for example, the Sahel, where you're going to generate major droughts. So this is not only a bad idea to do regional level geoengineering, but in fact it could be even create huge geopolitical conflict. So how do we set up our governance mechanisms in a way to make sure that these things don't happen? One really important challenge is also what kind of institution would we need to put in place to actually deliver such a system over many decades, possibly going into the hundreds of years. Something that has to go on, because once you start it, unless you have reduced completely the emissions to zero, you can't actually stop, or you can't stop quickly, because otherwise the temperatures would jump up to what they would have been otherwise. So you have to make sure that the institution that delivers this system is able to deliver this for a long time. And lastly, the last point, and this is absolutely essential, what people refer to as the moral hazard. This is not a technology that should tell us, okay, we do this and then we don't have to rush with our emission reductions. We have plenty of time because we've put a nice solar shield above our heads. That is absolutely the wrong way to approach this. we must reduce our emissions. That is the highest priority. Today, tomorrow, we got to do it. And yes, we are in a difficult situation, and maybe all that is not enough, and therefore we need to potentially consider these other options, but as supplements, not as a plan B. It would be an adjustment to plan A, if at all. But that requires this kind of broad societal discussion that I think all of us in this panel have been talking about, because it will have an impact on the people, on the economy, on the ecology, on all those different sectors, and we need to make sure that the representatives of those different sectors, whether they come from CAN, Friends of the Earth, private sector, governments, they all have to be part of that discussion. Thank you.
Thank you. Thank you.
So János, I think if we go back to the question, can we refreeze the Arctic? Even if the answer is yes, we can, the real question is, gosh, should we? The can we is not the right question. It's how do we govern the process?
Should we? And if we decide that yes, we should, how can we live with the consequences, and what framework do we need to develop so that we don't end up creating even bigger problems potentially?
But isn't there a fear that there may be people who say, oh, well, we can, so let's do it? And
but there are many things in the world we can do, but we don't want to do.
Exactly. And that's why we need to have these discussions.
Exactly.
Well, thank you. Thank you all. We do have just a few minutes left. Let's take one question, see if we have time for a second. The young lady in the center got her hand up first.
My name's Kate Aronoff with The Intercept. I have a question just around this question of governance. So it's clear that whether we're talking about mitigation or about geoengineering, specifically about aerosols and things like that, there are huge questions of governance and to get world countries to work together. I'm wondering sort of if you can articulate if you think it's more likely that world governments would work together towards something like geoengineering, and again, talking specifically about things like aerosols, these sort of new technologies that are largely untested.
I think that there is no clear indication that governments would be ready to do more international cooperation for, let's say, a solar geoengineering type of activity than what they are prepared to do for mitigation. But they are already doing quite a lot in the area of international cooperation for mitigation. It's just not fast enough and not enough. So neither in quantity nor in speed. So I wouldn't exclude that governments wouldn't be able to get together to do what if that were to be the case, and especially if the status quo continues and we find ourselves in a few years even more in the direction of a high climate change world, in which case they would be ready probably to do that.
Yeah, if I can jump in on this, I think it depends. Like you say, it depends on the task of governance, because governance is this broad term which includes many, many different things. In particular, having conversations, being coordinated, knowing what others are doing. And if we talk about governance of negative emissions, that's an entirely different thing than if we talk about governance of solar geoengineering.
Okay, I believe we're out of time, so let me just remind the audience that this has been a Climate Matters show. I'm your host, Stuart Scott, coming to you live from Bonn, Germany. And I'll ask the audience, please, here's a website I like to promote. It's an interesting idea to create a new push for sustainability in the world. Go check it out, np4sd.org. Thank you very much.